subject irrigation engineering, chapter irrigation efficiencies, topic water conveyance efficiency. So now students, now we will be discussing in this chapter about the various types of efficiencies that we generally see in the irrigation engineering subject, right? Okay, so now first of all, before explaining you anything, let me talk about what actually an efficiency is. So what is an efficiency? What is an efficiency? So you must be knowing, even in your elementary classes also you must have heard, right? Even if the not in the irrigation engineering other classes, you must have heard that efficiency is actually equal to output divided by input. Simple. So this is the basic definition of efficiency. If you want to calculate efficiency in percentage, it is multiplied by 100. Clear? And what about losses? What about losses? So you know that loss is equals to input minus output. So these are the losses, right? So these are the losses, right? So we have few types of efficiencies in irrigation engineering. So the first one is the water conveyance efficiency. And in this topic, that is the efficiencies, what I have seen that the students, they forget that which efficiency is what was there in the numerator, what was there in the denominator. So this is a very common mistake that students are making in GATE examinations, because as I have already told you that in GATE examination you have a tremendous pressure. So in that pressure, it is not sometimes the student, they are unable to recall that what was in the numerator and what was in the denominator. So let me explain you about the efficiencies so that you will be able to remember all the efficiencies, right? Okay, so first of all, let's come to the water conveyance efficiency. Now for example, for the water conveyance efficiency, let me give an example. Let us say that you have a canal, or let us say you have a river, right? Now from the canal or river, let us say that you have diverted a canal or diverted a river for a particular field, and let us say from the canal or river some volume of water is coming. Clear? Now what do you think? Do you think that all of the volume of water will be transferred to a particular field? No, this is not the correct answer. Why? Because there might be some losses. There might be some evaporation losses. There might be some infiltration losses in the bank, river bank. There might be some runoff losses also. So lot type of losses will be there. So it means that not all water will be transferred to a particular field. Simple. Let me draw one diagram also to make you understand. Let us say this was a canal. Let us say this was a canal, trapezoidal canal. So this is the water level in canal, okay? And this is a particular land that you want to irrigate, right? So what you have done is that now you have taken water from this canal. It can be either any process, right? So you have taken water from this canal, and let us say 5 kilometers away you have a field. So on this field you have transferred this water. Now what do you think? Let us say that the initial, let us say it was Q. Let us say it is Q1. So what do you think, this Q1 will be transferred to this particular field? No, there might be some evaporation losses, there might be some infiltration losses also, right? There might be some runoff losses, there might be some leakage in the particular channel also, right? It means that, suppose that this is Q2, the discharge which is which the particular plot or particular land is receiving. So we know that Q2 will be less than Q1, that Q2 will be less than Q1, clear? Or the volume 2 will be less than volume 1, right? So what about this time t, right? Let us say that I am calculating about volume, not discharge, let us say volume. So this is Q1 V1, this is Q2 V2. So I can say that Q2 is smaller than Q1, or V2 will be smaller than V1, right? V2 will be smaller than V1, clear? Okay. Now what about the losses? So initial it is V1 and final it is V2. So I can say that losses will be equal to initial minus final, or the input minus output. So input is V1 and output is V2. So these will be the losses. These will be the losses of water. Now what is water conveyance efficiency? It is actually denoted by neta C. C means conveyance, right? Okay. And neta is the symbol for efficiency. Some people say neta, some people say eta, right? So eta is the symbol for efficiency. So I can say that water conveyance efficiency is defined as, water water transferred to a particular field. Again I am repeating, the volume of water transferred to a particular field, volume of water transferred, or you can say volume of water received by the field, right? Volume of water received by field, divided by the volume of water discharged by the source, right? The volume of water discharged by source. So this is the definition of water conveyance efficiency. If you want to calculate it in percentage, then you have to be multiplied with percent also. Clear? Now sometimes in GATE examination I have seen that in numericals the water conveyance efficiency is not mentioned, but what is mentioned in numericals, it is mentioned like this, that the percentage losses of in carrying the water from a particular canal to a particular field are, let us say, 15% or 20%, right? Then you are given some numerical in which the use of water conveyance efficiency is there. So always remember, if losses are given to you in percent, again I am repeating, if losses are given to you in percent, then the water conveyance efficiency will be equal to 100 minus losses, right? Now I am writing it here. Note, if losses are given in percent, then water conveyance efficiency neta C will be equal to 100 minus loss percent. 100 minus loss percent. This is very simple. For example, let us say that 100% water was coming, but 20% is lost. So how much is left? Only 80% is left, and that is the efficiency. Simple, right? Okay. So these types of, you can see, numericals are also coming in examination, in which the losses are given, and what the students they do, the silly mistake, they don't read the questions carefully. Whenever they see the word conveyance, they will assume that it is the conveyance efficiency. No, you must see whether the losses have been mentioned or the conveyance efficiency has been mentioned. Okay? I hope that you have understood the water conveyance efficiency concept. Now let's move forward and solve one numerical based on the water conveyance efficiency. Thank you.